Today we're going to talk about the addition of vectors, and this is important when it comes to physics because in physics we add a lot of vectors. So if I were to be given this, I drew a picture. This would be 4, as in 4 miles an hour, at 20 degrees above due east. Okay? This would be 7, like 7 miles an hour, at negative 230. And remember, when you have a negative angle, that means you're going to go clockwise, clockwise from here, okay? So you're going 230 that way. And so these are the two vectors you're going to add. Now let me just give you a visual of what you're actually doing. You are actually taking this and then adding this vector to the end of it. So your resulting vector should be in the vicinity of that. So if your answer is not close to a vector that looks like that, then you know you've done something wrong. So when you add vectors, you take the tail of the second vector, put it at the arrow of the first one, and put it in the same direction. You're allowed to move vectors around. Okay, that's something that you learn in physics. So the way you do this is you have to add their components. Now remember, the components of a vector are its x component and its y component. Those are also known as rectangular coordinates. So to find those, this is the side adjacent, so the cosine of 20, okay, times the hypotenuse will actually give you the x coordinate. And the reason that is because the cosine of 20 equals adjacent over hypotenuse. So if I cross multiply, the hypotenuse times the cosine of 20 equals your x component. And your rectangular coordinates are always written x, y, alphabetically, so cosine and sine. So in order to do this, we can say 4 times the cosine of 20 plus 4 times the sine of 20, and then we put I to designate that it's the y component. This one would be 7 times the cosine of negative 230 plus 7 times the sine of negative 230, I. And then you would add those down. So on your calculator, you would say 4 times the cosine of 20, and you get 3.759 plus, and then you would do 4 times the sine of 20, and you get 1.368. Then you have 7 times the cosine of negative 230, and you get negative 4.5 because it's 4995 plus, and then you would do 7 times the sine of negative 230, and you get 5.362. Add those together. Make sure you add the signs correctly. So you have 3.759 minus 4.5, and you get negative 0.741 plus 1.368 plus 5.362, and you get plus 6.73I. Then you change these back into polar coordinates. So you would go to math, over to the CPX, down to angle, which is 4, and you would punch in negative 0.741 plus 6.73, I must have missed something, I, and close your parentheses, and you get 96.28 degrees. Now notice, this is 90 degrees, So 96.28 is right in the ballpark of the second vector we drew. So that's looking very good that this is a correct answer. So we do math, CPX, go down to ABS, which is 5, and you punch that in again. Negative 0.741 plus 6.73I, and we get 6.77. That looks very reasonable, that's what that would be. Remember, these are sketches. 7 probably is much longer than I drew it, but that looks like a very reasonable answer. So if I were adding two forces or two velocities or two of any vector quantities, because a vector quantity is a magnitude, which is a number, with a direction. A scalar quantity is just a number. So, for example, your mass would be a scalar quantity. Your weight, since it's your mass times gravity, and gravity has a direction, would be a vector quantity. Velocity is a vector quantity because it's a speed with a direction. Speed itself, like if I said 2 miles an hour, is just a scalar quantity because it does not have a direction. So that's how you would add vector quantities, and you can do that with any two vectors.